Okay, students. Now you have a very good understanding about what distance and displacement are, speed and velocity, acceleration, deceleration, and gravitational acceleration, and to draw graphs based on these quantities. So now we will do some questions related to these concepts. We'll start off with the miscellaneous exercise from your textbook. So the first question, explain the difference between distance and displacement. Second one, the path taken by a child in order to walk from a point to A to a point C is shown in the figure below. The figure is given to you. And the questions, what is the total distance traversed by the child? What is the displacement of the child? If the child walked from A to C via B in 5 seconds without stopping, find the mean speed, mean velocity of the child over the 5-second period. So now we will see how we can answer these questions. The first one, explain the difference between distance and displacement. You all know the answer to this? Yes, distance is the length of the path traversed by an object. So if we write distance is the length of the path traveled or traversed by an object. That is the distance. From one point A to another point B, the object can take any path. So the length of the path will be the distance between the 2 points. Whereas displacement, as you all know, it depends on the initial and the final positions. So here we define displacement as displacement is the change in position of an object. So those are the inner certain direction. So if you compare the two, distance is the length of the path traversed by an object, whereas the displacement is the change in the position of an object, and here we need to consider the direction in a certain direction. So that's how you are supposed to define distance and displacement. The next question, the path taken by a child in order to walk from a point A to a point C is shown in the figure below. So from point A, the child takes this path to point B. The length of the path is 15 meters. Then from point B to point C, the length is 20 meters. So the first question, what is the total distance traversed by the child? As you all know, for distance, we don't have to consider the direction because it is a scalar quantity. Therefore, we can directly add up the two values. So, distance is equal to the length of path AB plus the length of path BC. So, the length AB is 15 meters and the length BC is 20 meters. When you add them together, the total distance will be 35 meters. So directly we need to add the two values. We will go to the next question. What is the displacement of the child? So as you all know, students, displacement has a direction and the magnitude is the shortest distance between 2 points. So here if we look at the movement of the child from A to B, B to C, but the shortest distance is from A to C. So we need to have the length of that path, the path in a straight line, which is the shortest distance. And if you can remember, as looking at this particular diagram, you can see that this is a right angle triangle because it is 90 degrees. Therefore, you can apply the Pythagorean theorem and calculate the length of AC. So, to do that, we have to use this equation AC squared, that is equal to AB squared plus BC squared. So here the AB, you know the value 15 meters. So that has to be 15 squared plus BC 20 meters, 20 squared. So 15 squared is 225 meters plus 20 square is 400. Then when you add up 225 plus 400, it will be equal to 625. That is AC squared. In order to find the length of AC, we need to get the square root. AC will be equal to square root of 625. If we get the value, it will be equal to 25 meters. So 25 meters is the length of A to C. And here, since it is the displacement, we have to write it as displacement equals 25 meters, and we have to specify the direction from A to C. Since the letters are given, we use them to denote the direction. So, displacement is 25 meters from A to C. Next question. If the child walked from A to C via B in 5 seconds without stopping, find the mean speed. So, mean speed is the total distance traversed divided by the total time taken. So, here if we write the equation for mean speed, total distance divided by time duration. We already calculated the total distance 35 meters divided by, here the time is given to you 5 seconds. So when we calculate the value 35 divided by 5, it will be 7 meters per second. So here this is 35 and 5 seconds. 7 meters per second is the speed. Then mean velocity of the child over the 5-second period. That's the second part of the question. So here we need to consider the displacement of the child. When we say mean velocity, it is the total displacement over time. And in the previous question, we calculated the displacement as 25 meters from A to C. The length was 25 meters. So we can substitute that value here, 25 meters divided by again the same time duration, 5 seconds. So that will be equal to 25 divided by 5 meters per second. And this also has a direction that again is from A to C. So as you can see, students, the mean velocity of the child during the 5-second period is 5 meters per second. And the child moves from A to C. Therefore, we can include the direction with the velocity. As you know, velocity is a vector quantity. So, if we can include the direction, it would be better. So, here 5 meters per second from A to C. So, that is the velocity of the child. Now, we will go on to the next question. Briefly explain the difference between scalars and vectors. Classify the following physical quantities as scalars or vectors: distance, displacement, speed, velocity. Then the third part, the displacement time graph of an object moving along a straight line is shown in the figure below. Here they have shown the displacement of an object. You can see displacement is given in S meters, that is the unit of displacement, and here is the time, it has to be in T seconds. So this will be T seconds. And the questions are, how far has the object moved after starting from rest? Second one, how long has it taken to travel the above distance? Find the maximum velocity of the object during that period. What can you say about the motion during the interval from 4 to 6 seconds? Comment on the motion during the interval from 6 seconds to 8 seconds. 6 seconds to 8 seconds. So, we will answer the questions one by one now. Briefly explain the difference between scalars and vectors. When we say scalars and vectors, the scalar quantity and the vector quantity. I'm sure you remember these, students. The scalar quantity is the physical quantity that can be described only by its magnitude. So, if we write the definition for scalar quantity is the physical quantity that can be described only by its magnitude. Only by its magnitude. And then you know the vector quantity. For vector quantity, we have to give the magnitude and the direction. So, vector quantity is the physical quantity that can be described by its magnitude and direction. So the scalars and vectors, for both you have to say that they are physical quantities, and for scalar or scalar quantity you have to say only by its magnitude, and for vector quantity you have to say magnitude and direction. If you remember those important points, then you can answer these questions easily. The next one, classify the following physical quantities as scalars or vectors. So, if we classify them as scalars and vectors, then we have first the distance. Distance, you know, does not have a direction. Therefore, it comes under scalar quantity. It is only the length of the path travelled by an object. So, distance is a scalar quantity. Then displacement on the other hand has a direction. So, therefore, displacement is a vector quantity. Then we have speed. Speed again doesn't have direction. It is the rate of change of distance. So, here it is the speed that comes under scalar quantity. And finally, velocity has a magnitude and direction. Therefore, it is a vector quantity. So, distance and speed are scalar quantities. Displacement and velocity are vector quantities. The next question, the displacement time graph of an object moving along a straight line is shown in the figure below. So, when you look at the graph, first make sure you look at the axis carefully. So, the y-axis is displacement and x-axis is time. So, how far has the object travelled? So, in order to identify that, first get an idea about the shape of the graph. That means the way the object has travelled. So, starting from time 0, that is starting from 0 point is the rest, initial point, initial position. The object has moved a displacement of 10 meters in 4 seconds. So, the first 4 seconds it has travelled 10 meters in a certain direction. And here you can see it is a straight line. So, you can get the information that it has to be uniform velocity. Then from this point until the end of 6 seconds, you can see it is a flat line parallel to the time axis. So, that means there is no change in the displacement. Then obviously the object has to be in the same place, that is at rest. And finally, 6 seconds to 8 seconds, the object goes back. If the slope is in the opposite direction, that means the object is moving backwards. And finally, it touches the x-axis. So, displacement is 0. Therefore, it is moving in the opposite direction. So, now you have an idea about the movement of the object. Now, we will go on to the questions. To find how far the object has travelled, we have to find the displacement of the object in the first 4 seconds from the graph. So, that you have already identified, displacement is 10 meters. So, the object has travelled a distance of 10 meters from the starting point. So, to answer this question, you can say the object has moved 10 meters after starting from rest. This will be the answer. Now the next question. How long has it taken to travel the above distance? So how long? The first distance, that is 10 meters, it took 4 seconds. We can write the answer as 4 seconds. Then the next question, find the maximum velocity of the object during that period. So maximum velocity from the displacement time graph, you know students, it is the gradient of the displacement time graph that will give you the velocity. So to calculate the velocity, we need to divide y by x. The change in y divided by change in x. So velocity is equal to the gradient of the graph. To calculate the gradient, we need the difference in y. So final displacement is 10, initial is 0. So 10 minus 0 divided by the x-axis, that is the time, 4 minus 0. That will give you a value 10 divided by 4, 2.5 meters per second. Why? The y-axis, the unit is meters, x-axis, the unit is second. So meters per second. So velocity will be 2.5 meters per second. Next question. What can you say about the motion during the interval from 4 seconds to 6 seconds? So as we discussed before, 4 seconds to 6 seconds, there is no change in the displacement. It remains at the 10 meter point. So that means the object is not moving or the object is at rest. So we can write the answer as object is at rest. Object is at rest. Next one, comment on the motion during the interval from 6 seconds to 8 seconds. So as you can see, initially the object came to the point where the displacement is 10 meters and then it went back to the point where the displacement is 0. So that means the object traveled in the opposite direction and reached the starting point. So we can write the answer as the object traveled in the opposite direction. And reached the starting position. So that means there is no final displacement. The next question, if the velocity of a body varied uniformly from 10 meters per second to 25 meters per second during a time interval of 5 seconds, what was the acceleration of the body? When you read the questions, you have to get the information from the question. Uniformly 10 meters to 25 meters and time is 5 seconds. Sketch the velocity time graph for the above motion and find the distance traveled during the 5 seconds. The variation of the velocity of a certain object that travelled along a straight line is shown in the graph. This is another graph, another object, another graph. Find the acceleration of the object during the first 6 seconds. Find the distance traversed by the object during the first 6 seconds. What is the distance traversed at a uniform velocity? And finally, find the deceleration during the last 3 seconds. Those are the questions. We will go to the first one. If the velocity of a body varied uniformly from 10 meters per second to 25 meters per second and time is 5 seconds. When you read the question, you can note down the important data. And then we have to calculate the acceleration. What is acceleration? Yes, it is the rate of change of velocity. So, we have to divide velocity by time. When we say rate of change of velocity, it has to be the final velocity minus initial velocity divided by time. In this question, all the values are given directly. Final velocity 25, initial velocity 10 and time 5 seconds. So, you can include the units 25 minus 10 meters per second and 5 seconds. So, 25 minus 10, it is 15 meters per second divided by 5 seconds. That will be equal to 3 meters per second square. So, that is the acceleration of the object. Next one. Sketch the velocity time graph for the above motion and find the distance travelled during the 5 seconds. So, we have to find the distance travelled during the 5 seconds. To do that, first we have to draw the velocity time graph. So, you know what has to go to the x-axis. It has to be time. And we have to put the unit seconds. And here we need to have velocity that will be in meter per second. That is the unit of velocity. And you know the time duration, it is 5 seconds. So, let me mark 5 seconds here. And you know the initial velocity and the final velocity of the object. The object starts at 10 meters per second. That is this point. Then it reaches a velocity of 25 meters per second. So, I have marked the two values here. So, starting from the initial velocity 10 meters per second, the object has to reach a velocity of 25 meters per second. So, if I draw the graph, it will start from this point and come up to there. In 5 seconds, it has reached the velocity of 25 meters per second. Now, the calculation. We need to find the distance travelled during the 5 seconds. So, to do that, you can remember what do we need to calculate? We need to calculate the area covered under the graph. So, we have the area that is under this graph, this whole area. So, here if you look at the shape, This is a trapezium. So we need to find the area of the trapezium. So if I do the calculation here, distance equal to area of trapezium. So I will do the calculation. That will be equal to the sum of the parallel sides divided by 2. So if we take the parallel side, the length of this side is 10 and the length of the long side is 25. That has to be divided by 2, and then we have to multiply by the perpendicular height. That is the time taken for the movement. So that is going to be 5. If I do the calculation, 10 plus 25, 35 divided by 2 into 5. So here 35 divided by 2 is going to be 17.5, and if we multiply that by 5, you will get a value of 87.5 meters. So that is the distance traveled during the 5 seconds. So remember students, the area under the curve. So that is the area of the trapezium. And we have calculated the distance traveled as 87.5 meters. Now the next question. The next question, the variation of the velocity of a certain object that traveled along a straight line is shown in the graph. So again, look at the graph. The first 6 seconds, velocity goes from 0 to 6. The next 6 to 12 seconds, that is the next 6 seconds, the velocity does not change. And finally, from 12 to 15 seconds, the velocity decreases and comes to 0. So you all know the different types of motion involved in this graph. Find the acceleration of the object during the first 6 seconds. So from the graph you know the first part is acceleration. This is acceleration. The second part from 6 to 12 seconds, that is uniform velocity, because the graph is parallel to the x-axis and the value of the velocity does not change. And finally, it is deceleration or minus acceleration. So the question is, find the acceleration of the object during the first 6 seconds. So as you know, acceleration is the, what is this? Y divided by x is the gradient. So acceleration is equal to the gradient of the velocity time graph. So we can write it as acceleration equals to gradient, and that will be equal to 6 minus 0, the difference in y-axis, and 6 minus 0, the difference in x-axis. So on top we have the unit meter per second and we divide that by seconds. So that is equal to 6 over 6, 1 meter per second square. The acceleration of the object is 1 meter per second square. The next question. Find the distance traversed by the object during the first 6 seconds. As you know, the displacement without the direction is the distance. So here, from the velocity time graph, in order to calculate the displacement, we need to calculate the area of the curve, area under the curve. Here, since it says distance traversed during the first 6 seconds, the area is the area of the triangle. So, if we find the area of the triangle, we can find the distance traversed. So, distance traversed is equal to area of the triangle, that is equal to half into base into height. So, we calculate the area of this triangle, that will be equal to half into base, you can see 0 to 6. So, 6 into height is again this height. So, from 0 to the point again 6 there. So, here half into 6 into 6. Here you can cancel off half and 6. So, 2 can simplify 6. So, it will become 3. 3 into 6 becomes 18 meters. So, the distance traversed by the object within the first 6 seconds is equal to the area of the triangle, and that is equal to 18 meters. Then the next question, what is the distance traversed at a uniform velocity? As we noted before, uniform velocity is from 6 to 12 seconds. So, we need to calculate the area of this square. We have to calculate the area of the square, which is the area under the graph with uniform velocity. So, the distance traversed here will be equal to area, if we mark these points as A, B, C and D, it is actually a square. Area of square ABCD, that is equal to length into breadth. So, here you can see length from 6 to 12, we have to take only the difference. 12 minus 6 will be 6. If you want to be sure, you can write it down and find the difference. 12 minus 6 into the height is 6 again. So, 6 into 6, it will be equal to 36 meters. That is the distance traversed by the object with uniform velocity. Next question. Find the deceleration during the last 3 seconds. So, this is the part where we have the deceleration. Initial velocity 6, final velocity 0. It comes to rest, and the time periods are 15 and 12. So, now we need to calculate the deceleration. Deceleration is not directly calculated. Instead, we calculate the acceleration of the object. So, you have to write the equation for acceleration. Acceleration equals the gradient of this graph. So, we write it as gradient, and that is equal to, here you can see the final minus the initial. The final value is 0, initial value is 6. So, 0 minus 6 divided by the time is final 15, initial 12. So, 15 minus 12. When you subtract 6 from 0, you get the value as minus 6. Minus 6 is the value. 15 minus 12 is 3. So, when we divide minus 6 by 3, we get the value minus 2 meters per second squared. How do I get this unit? It is meters per second in the y-axis and per second in the x-axis. ms minus 1 divided by second is ms minus 2. So, we get the answer as minus 2 meters per second squared for acceleration. Then we have to rewrite it as deceleration is equal to, when we rewrite minus acceleration, we take off the minus, we write it as deceleration, 2 meters per second squared. So, that is the deceleration of the object during the last 3 seconds. This is the fourth question. An object starting from rest and moving on a straight line at a constant acceleration acquires a velocity of 12 meters per second in 8 seconds. Thereafter, it moves for another 4 seconds at a uniform velocity of 12 meters per second. Ultimately, it decelerates for 4 seconds and comes to rest. The questions: sketch the velocity time graph for the above motion. What is the acceleration of the object during the first 8 seconds? What is the distance traversed by the object during the first 8 seconds? What is the distance travelled at uniform velocity? What is the deceleration of the object during the interval from 12 seconds to 16 seconds? What is the displacement of the object after 16 seconds? The first question: an object starting from rest and moving on a straight line at a constant acceleration acquires a velocity of 12 meters per second in 8 seconds. Thereafter, it moves for another 4 seconds at uniform velocity of 12 meters per second. Ultimately, it decelerates for 4 seconds and comes to rest. So, those are the points that we need to get from this data. Then, if we plot the graph, they have asked us to sketch the velocity time graph for the above motion. So, again, the time goes to the x-axis. We have to label it first. Time t seconds, and velocity in y-axis, velocity v meters per second, and we can mark the values. Initially, in the first 8 seconds, the velocity comes to 12 meters per second starting from rest. So, if I mark the value for the time, 4, 8, 12. Yes. And 16. So, the first 8 seconds with constant acceleration for another 4 seconds. So, that means 8 plus 4, 12. It goes with uniform velocity, and finally for the last 4 seconds, that is up to 16 seconds, it will be deceleration. And then if we mark the value of velocity, 12 meters per second, then we will have to plot the graph. Starting from 0, it goes to the velocity 12 within the first 8 seconds. So, to draw the graph, we can first mark the coordinates. Time 8 seconds. So, starting from this point, it comes to 12 meters per second, and here we have 12 meters per second. So, I will plot the graph starting from 0. it reaches a velocity of 12 meters per second. Then the second part of the motion, uniform velocity for 4 seconds. So again another 4 seconds, that is uniform velocity. If we are to mark the values, it will come up to 12 seconds. And finally the 16 seconds. If I plot the graph, it will be from 8 to 12 seconds, a straight line parallel to the x-axis. And finally decelerates for 4 seconds until it comes to rest. So starting from this point, it will decelerate and come to the 0, that is the x-axis. So this will be the graph related to this motion. Initially accelerates and reaches a velocity of 12 meters per second, uniform velocity for another 4 seconds, and finally decelerates for the last 4 seconds. Okay, right. So as you can see, this is the graph. Initially starting from 0, the object reaches a velocity of 12 meters per second, moves with the same velocity for another 4 seconds, and finally decelerates and comes to rest within the last 4 seconds. So this is the velocity time graph for the motion of this object. Then the questions. What is the acceleration of the object during the first 8 seconds? Acceleration is the gradient of the first part of the graph from 0 to 8 seconds. So we will have to write it as acceleration, that is equal to the gradient of the graph. When we say gradient, difference in y-axis minus the difference in x-axis. So gradient, difference in y-axis divided by the difference in x-axis. That is equal to 12 is the final value, 0 is the initial value, divided by 8 is the final, and initial time is 0. So again you will get the values as 12 divided by 8, that is equal to 1.5 meters per second squared. Again velocity meter per second, time second. So when we divide, we get the unit as meters per second squared for acceleration. The next question is, what is the distance traversed by the object during the first 8 seconds? So here you can see first 8 seconds is this part of the graph. Even in the previous one you saw that it is this part of the graph, that is the acceleration. So first 8 seconds, then we have to calculate the area covered by this graph. That will be the distance traversed by the object during the first 8 seconds. So to do that, we have to write distance traversed will be equal to area of the triangle. If you want, for your convenience, you can even mark the graph as points A, B, C and D. So here if I mark the, I'm not marking the point since it's shown to you in the graph. It has been shaded. So here the area of a triangle is equal to half into base into height. So half, and to get the base value, that is the x-axis 0 to 8. So base is 8 and height is this perpendicular height. That is the value of the velocity. From 0 to 12 is the height. So we have to write 12 as the height of the triangle. You can simplify 2 and 12, 6. 6 into 8, 48, and the unit will be meters. Why? We have meters per second in the y-axis being multiplied by second in the x-axis. So the final unit is meters. So the distance traversed by the object during the first 8 seconds is the area covered by the graph, and that is 48 meters. What is the distance travelled at uniform velocity? So uniform velocity, if we are to show it in the graph, it is these 2 points from 8 seconds until 12 seconds, and that is the area under this graph. So this is a rectangle. If we calculate the area of the rectangle, it will be equal to the distance travelled at uniform velocity. So distance travelled with uniform velocity is equal to area of the rectangle. For the area of the rectangle, we need to multiply the length into breadth. So 8 to 12 is the length of the triangle. It has to be 12 minus 8, only the length, only this particular distance. So 12 minus 8 into the height is 12. So that will be 4 into 12, 48 meters again. Distance, the unit is meters. The next one, what is the deceleration of the object during the interval from 4 to 16 seconds? If we are to find the deceleration, this part of the graph is for the deceleration. If we calculate the gradient of this plot, that is this part, we will get the deceleration of the object. So to do that, we will have to write it as I said before, we don't directly write as deceleration. You have to write it as acceleration equals gradient, and that is equal to gradient, final value is 0 here and initial value is 12, and the time is from 12 to 16 seconds. So final value 0 velocity, initial velocity 12, that is the difference in y-axis, and the time 16 minus 12. So this will be minus 12. 0 minus 12 will give you a negative value, minus 12 divided by 4, that is equal to minus 3, and the unit will be meters per second square. So when you get the negative value for acceleration, we rewrite it as deceleration equals 3 meters per second square. So that is the deceleration of the object during the time interval from 12 to 16 seconds. Now we will go to the next question. What is the displacement of the object after 16 seconds. So here when they mean after 16 seconds, they mean the total up to the end of 16 seconds. So we can take it as displacement of the object till the end of 16 seconds. So that is the area covered by the full graph, because the object traveled for a total time duration of 16 seconds. So this shape you all know, yes, it is a trapezium. So the area of the full trapezium will give you the total displacement of the object. So this is equal to area of the trapezium. So that is equal to area of the trapezium, the average of the length of the two parallel sides. That is, if we mark it as A and B, A is equal to from 8 to 12, so that is 4, and B is equal to 16. So if we write the area of the trapezium, A plus B divided by 2 into the height. That is the 12 meters, the perpendicular height. So that is equal to, again, A is 4 and B 16 divided by 2 into height 12. That will be equal to 20 divided by 2 into 12. When you simplify 20 and 2, you can simplify it as 10. That will be equal to 10 into 12 equal to 120 meters. So the displacement of the object at the end of 16 seconds is equal to 120 meters. That is the area covered by the trapezium. I hope you understood the calculation related to all these questions of the graph. We'll go on to the next question. An object starting from rest and traveling along a straight line takes 8 seconds to acquire a velocity of 16 meters per second. Next, it moves at a uniform velocity for 4 seconds and ultimately decelerates for 4 seconds before coming to rest. That is the motion of the object. 8 seconds to acquire a velocity of 16 meters per second, then uniform velocity, and finally deceleration. The questions are: sketch a velocity time graph for the above motion. Find the deceleration during the first 8 seconds. What is the distance traversed by the object during the first 8 seconds? What is the distance traversed at a uniform velocity of 16 meters per second? Find the deceleration during the last 4 seconds. And what is the distance moved during the last 4 seconds? We will answer the questions one by one. The first one, we have to draw or sketch a velocity time graph. So here, when they mean sketch, you have to label the axis and the points have to be marked, and you have to draw the graph according to the correct shape, so that as you look at the graph, you get an idea as to what has happened to the object. So we will start by marking the axis. So the y-axis here is velocity, meter per second. We can write the symbol V, velocity V, meters per second, and the x-axis is time t, unit is second. Then we have to mark the time period. Initially 8 seconds, then 4 seconds, and finally 4 seconds. So we can mark 3 squares, 4, 8, 12 and 16. Those are the time values that we need, and the velocity, the maximum velocity acquired was 16 meters per second. So here I can mark the value as 16 there. So initially, if we are to draw the graph, if I show you all the values, the first 8 seconds, it was acceleration starting from 0. So for the first 8 seconds, if we mark the values up to here and 16 seconds, then it was for the next 4 seconds. So that will be these 2 points with uniform velocity, and finally the end of the motion where the object reaches 16 seconds. We will draw the graph. Initially, starting from 0, the object acquires a velocity of 16 meters per second. So start from the 0 point and go up to the 16 meters per second mark. Then the second part, uniform velocity for 4 seconds. That is this part where from 8 seconds to 12 seconds is the 4 second time period. 8 plus 4, 12. So uniform velocity. And finally, decelerates for 4 seconds before coming to rest. So starting from 0 point, the velocity comes to 0 after 4 seconds of deceleration. This will be the graph for the motion of this object. So this is how you have to draw the graph. You have to mark the 2 axes, time and velocity, mark the values, and then plot the graph or sketch the graph. Now we will look at the questions. Find the deceleration during the first 8 seconds. Students, you can see here the velocity goes from 0 to 16, and in the question also it says it is acceleration. So this should have been acceleration, not deceleration. It has to be acceleration. So we need to calculate the acceleration during the first 8 seconds. So that is the gradient of this graph. So if we write the answer, acceleration equals the gradient of the graph. To calculate the gradient, we have to find the difference in the y-axis, 16 minus 0, divided by the difference of the x-axis, that is 8 minus 0. So that is 16 minus 0, 16, 8 minus 0, 8 meters per second divided by second, that will be 2 meters per second squared. So the acceleration of the object during the first 8 seconds is 2 meters per second squared. The second one, or the third question in this, under this graph, what is the distance traversed by the object during the first 8 seconds? So here, what is the distance? Here we will have to find the area covered under the graph. So that is going to be this area of the triangle. That will be the distance traversed by the object during the first 8 seconds. We can label the triangle as A, B, C. Then we will calculate the distance traversed by the object using the area of this triangle. So when we write it down, distance equals area of the triangle. So when we say area of the triangle, the equation is half into base of the triangle into the height of the triangle. So here we write the half. Then for base it will be from 0 to 8. That is AC, 8. And the height is going to be from C to B, that is 16, value 16. So if I write 16 here, then we can simplify 2 and 8 becomes 4, and when you multiply 4 into 16, it becomes 64 meters. And as you can see, the base is in seconds and the height is in meters per second. So meter per second into second, the second minus 1 and second will cancel off. So we will get the unit as meter. The distance traversed by the object during the first 8 seconds is equal to 64 meters. Now we will go to the next part of the question. What is the distance traversed at uniform velocity of 16 meters per second? That is going to be this part of the graph where you have a graph parallel to the x-axis. We will have to calculate the area covered by this part of the graph. Normally, when the velocity time graph is parallel or a straight line parallel to the x-axis is a uniform velocity. So the area is going to be the area of the rectangle. Here we can say distance traversed equals the area of rectangle, that is equal to the length into breadth. 12 minus 8, that is this part of the graph. You have to calculate the difference only the length of this rectangle, and this part is 16. So 4 into 16, 12 minus 8, 4 into 16 is going to be 64 meters. So that is the distance traversed with uniform velocity. Next one is to find the deceleration during the last 4 seconds. So here you can see this part where you have the negative slope is the part where the object decelerates. So again we have to write it as acceleration equals gradient. Students, when you calculate, always you have to write what you are calculating, and you have to either write down the equation, or if it is from the plot, it is better to write whether it's the gradient or the area, so that you won't make a mistake. So here the gradient is the difference in y-axis divided by the difference in x-axis. So y-axis final value is 0, this point, and the first part is here. So final minus initial, 0 minus 16, and the difference in x-axis final minus initial is going to be 16 minus 12. So those are the values. Then you will get minus 16 divided by 16 minus 12, 4. So minus 16 divided by 4 will give you minus 4, and the unit is going to be meter per second square. This is a negative acceleration. So we rewrite it as deceleration. Deceleration is equal to, here we write it as a positive value, 4 meters per second square. So that is how we calculate the deceleration from the graph. Then the next question, what is the distance moved during the last 4 seconds? The last 4 seconds is deceleration. They want us to calculate the distance. So that will be equal to the area covered by the graph. So if we identify the area covered by the graph, that is going to be this triangle. So if we calculate the area covered under this triangle, we will get the distance moved during the last 4 seconds. So distance equals area of the triangle so that is again equal to half into base into height. So here the base is 16 minus 12. So half into base, you can even write it here as 16 minus 12 into height is this height 16 meters. So half 16 minus 12 is 4 into 16. When we simplify 2 and 4 becomes 2 here. So 2 into 16 we get the value 32. And since we multiply meter per second by second, this will have to be meters. The unit is meters. So we get on to the next question. A fruit in a tree that detaches from the stalk takes 4 seconds to fall to the ground. So when you say an object falling from a certain height coming down to the ground, so you will know it is with the gravitational acceleration. What is its velocity when it reaches the ground? What is the height that it fell from? An object is projected vertically upwards at an initial velocity of 30 meters per second. Find the time taken by the object to reach its maximum height. What is the maximum height reached by the object? Sketch the velocity time graph for the motion of the object from the time it was projected until it reaches the maximum height. So those are the questions related to the motion of these objects. We will answer the questions one by one. So the first one, a fruit in a tree that detaches from the stalk takes 4 seconds to fall to the ground. So that means in this question you have to remember that there is an object at a certain height and it is falling downwards. So it is the gravitational acceleration g, and you should remember the value 10 meters per second square. Normally they give you the value, but still you should remember the value of gravitational acceleration. It is 9.8 meters per second squared, but for calculations, we take it as 10. So, initially the velocity will be 0. Why? The object is detached from the fruit is detached from the stalk. So, initially it's 0 and finally when it reaches a ground, it will have a certain velocity. That is what they want us to find. Velocity when it reaches the ground. So, we know that acceleration is rate of change of velocity. That is final velocity minus initial velocity divided by the time taken. So, here if we write it as gravitational acceleration, or you can even write it as acceleration, G equals final velocity minus initial velocity divided by time. So, here G equals 10, that is equal to, we will take the final velocity as V minus 0, and you already know the time 4 seconds. So, 4 seconds here. When we rearrange this equation, I will do it on this side. So, you will have 10 into 4, that will be equal to V minus 0. So, 10 into 4 is 40, that is equal to V. Therefore, the velocity equals 40 meters per second. Then the second question, what is the height that it fell from? They want you to calculate this height h. So, here again we have to relate it to the two velocities. If you remember, students, when an object moves with uniform acceleration, the displacement is equal to mean velocity into time. So, here the height is the displacement of the fruit. So, to calculate the height, we will have to write it as mean velocity into time taken. So, to calculate the mean velocity, final velocity 40 meters per second plus initial velocity 0 divided by 2 is the mean velocity into time 4 seconds. So, that will be equal to 40 divided by 2 into 4, that is equal to 80 meters. That is the height of the fruit. What is the height that it fell from? The next question, an object is projected vertically upwards at an initial velocity of 30 meters per second. Find the time taken by the object to reach its maximum height. So, here what we do is we throw an object upwards. So, as you know, students, when we throw something upwards, the acceleration, that is the gravitational acceleration, is going to act downwards. So, little by little the velocity will decrease and finally the object will get a velocity 0. And at this point the object will be at its maximum height. So, initially we are projecting the object upwards with a velocity of, you can see, 30 meters per second, And when it comes to the maximum height, velocity will be 0. And this is the height that we need to calculate, or the time taken needs to be calculated. And as you can see, since the gravity is acting downwards, the object is moving upwards, so it is going to be a deceleration. So it is going to be minus 10 meters per second squared. That is the value of the gravitational acceleration, which becomes the deceleration here. So we need to find the time taken by the object to reach its maximum height. The values we know are the initial velocity, final velocity, and the deceleration. So if we write the equation for deceleration, or in other words acceleration, acceleration is the rate of change of velocity. So that is final velocity minus initial velocity divided by time. So here I will write the equation as acceleration equals final velocity minus initial velocity divided by time. So from this we can calculate the time. If I substitute the values here, acceleration is a negative value, minus 10 meters per second squared, and the final velocity you can see is 0. Initial velocity is 30 meters per second, and time will be t. For velocity, the unit is going to be meters per second. And here we can rearrange the equation. T can be taken as the subject. So here when you calculate 0 minus 30 is minus 30 meters per second, and the minus 10 meters per second has to come this side. So it becomes minus 10 meters per second squared. When we divide the value, the minus and minus will get cancelled off. These two will get cancelled off. So 30 divided by 10 will be equal to 3. Here we have the unit meters per second. Here we have the unit meters per second squared. So when they get cancelled off, you will end up with the unit second. Here you will get s minus 1. When you take that up, it becomes second. So automatically you get the time as 3 seconds. The time taken by the object to reach its maximum height is 3 seconds. Then the next one, what is the maximum height reached by the object? So here the maximum height that we have taken as h is the displacement of the object. As you know, when an object moves with uniform acceleration or uniform deceleration, the displacement is equal to average or mean velocity into time. So that is what we are going to use here. Height is equal to displacement that is equal to average velocity into time. So when we say average velocity, initially the velocity is 30, finally the velocity is 0. We just add them together and divide by 2, and time is going to be, we have already calculated, 3 seconds. So that will give you 30 divided by 2. That will be the average velocity meters per second into 3 seconds, that is equal to 15 into 3, 45 meters. So here the meter per second and second get cancelled off. So we get the unit as 45 meters. The maximum height reached by the object is going to be 45 meters. We'll go to the next question. Sketch the velocity time graph for the motion of the object from the time it was projected up until it reaches the maximum height. It should be projected up until it reaches the maximum height. So here, as you know, initially the object was thrown upwards or projected upwards, then it decelerates, reaches the maximum height, and then due to gravitational acceleration, it will again come downwards to the ground. So if we consider the movement, this is the ground level, this is the height h. So initially it moved upwards and then finally it is going to come downwards. Both ways, the velocity at this point is going to be 30 meters per second as given in the question. And here the velocity is going to be 0. Time taken for the object to reach the maximum height was 3 seconds. So here there was 3 seconds, and finally for the object to come down, it will also take 3 seconds. Because it is the same height, initially the same deceleration, now it is the same magnitude of acceleration, the gravitational acceleration. So the time is going to be the same. The initial velocity here and final velocity here are the same, and at the maximum height it is 0. We will get a graph that will have values on either side of the y-axis, the positive part of the y-axis and the negative part of the y-axis, because the motion changes direction. Initially the object goes up, then the object comes down, and initially it is decelerating, then it is accelerating. So therefore, first the velocity decreases, then the velocity increases in the opposite direction. So therefore, when we plot the graph here, we will have to consider the graph that is going to be the velocity time graph. So I will label the axis first, time, t, seconds, and on this side it's going to be velocity, v, meter per second, the unit. And here, if you need, you can check it again. The maximum velocity with which it was thrown upwards is 30 meters per second. So, but since I said the graph is going to be on either side, I will mark the 0 point at the middle of the graph. We will mark 0 here. So it will be 30 meters per second on one side. The other side, it will have a value of minus 30 meters per second. Going upwards, we take it as the positive direction. Coming down will be the negative direction. I will mark the x-axis. The first part of the motion is 3 seconds to go up and reach the maximum height, and then coming down it takes another 3 seconds. So a total of 6 seconds for the full motion. And if we plot the graph, you can see that it is going to be the movement where it starts from 30 and at 3 seconds the velocity becomes 0, and then when the object comes down, it is going to be velocity in the opposite direction. So at the end of 6 seconds, the velocity minus 30 will be reached. That is because it is going to be in the opposite direction. So if we plot the graph, it is going to be like this. If we mark the sections up to this point, it is the object going upwards, and the rest of it is where the object comes down again. Starting from 0 velocity, accelerating in the opposite direction and reaching a velocity of minus 30 meters per second. So remember students, when an object moves in the opposite direction as well as it accelerates in one direction and decelerates in the opposite direction, you will have to draw a graph where you will be using the positive and negative parts of the y-axis. So students, I hope you understood the way of calculating displacement, velocity, acceleration and getting information from the graph. So this is the last question in your textbook miscellaneous exercise. Now we will do some more extra questions. Extra exercise 1. The following diagram is a sketch of a velocity time graph for the motion of an object. So here the velocity in the y-axis, time in the x-axis, and the units are given meters per second and time second. The questions are: describe the parts of the motion A, B and C. And here, during what part of the motion an external unbalanced force is not applied on the object. So we'll answer the questions. The first one, describe the parts of the motion A, B and C. So here, since this is a velocity time graph, when you get a straight line going through the point of origin, that is the 0, 0 point, and it is a straight line, you know that the velocity is increasing uniformly with time. So what is the name given to that type of motion? Yes, it is uniform acceleration. So A is going to be uniform acceleration. Then we have B. This is a part where the motion, the graph is parallel to the x-axis. So in a velocity time diagram, if it is parallel to the x-axis, that means the velocity is not changing. Then what do we call that motion? Yes, it is called uniform velocity or constant velocity. So the B part of the motion is uniform velocity or constant velocity. Then the last part of the motion is C, where there is a velocity at the beginning and finally at the end of the motion the velocity is 0 and it is a straight line with a negative gradient. So it has to be uniform deceleration. So C part of the motion is uniform deceleration. Okay, we'll go to the next question. During what part of the motion an external unbalanced force is not applied on the object. Now students, think of an object on the table, right? It is at rest. There is no external force. You push the object, it will move towards the direction that you push, or if you pull the object, it will move towards you. So this push and pull are the external unbalanced forces. So when you apply an external unbalanced force, the object will move. So if you don't apply an external unbalanced force, the object will be at rest. Another thing, now when you are traveling in a car, you would have seen when the driver applies the brake, the moving vehicle will decrease speed or come to a stop. If you press the accelerator, the speed of the vehicle will increase. So, in order to change the speed or the velocity of an object, you have to apply a force. That is also an external unbalanced force. So, if you don't apply an external unbalanced force, an object will move with uniform velocity or it will be at rest. So, here the question is, during what part of the motion an external unbalanced force is not applied on the object? B part of the motion is uniform velocity. So, the velocity does not change. So, that means during this part of the motion, that is B part of the motion, there is no external unbalanced force. So, answer to this question is going to be B part of the motion. B part of the motion. Or in other words, you can write when the object moves with uniform velocity. Within brackets, I will write that also. This is when object moves with uniform velocity. Those are the two questions. We will go on to the next question. Extra exercise 2. The following displacement time graph illustrates the motion of an object traveling towards the north in a straight line. So, here they have mentioned the direction. So, when you consider displacement or velocity, you have to consider this direction north. If we look at the graph, initially the object starts from 0. That is the initial point. And within 10 seconds or at the end of 10 seconds, the object displaces to 20 meters. And then until 14 seconds, the displacement is the same. So, there the object is not moving. It is at rest. And finally, it takes another, now if you take the difference, 20 minus 14, so another 6 seconds to come back to the initial position. That is why again the displacement is 0. So, here are the questions. Find the total distance traversed by the object. What is the displacement of the object at the end of the journey? Calculate the maximum velocity of the object. Find the distance traversed by the object during 10 to 14 seconds. Plot the velocity time graph for the above motion. We will answer them one by one. The first part, find the total distance. So, when we say total distance, it is the total displacement. Here, it is the displacement but without the direction. So as you can see, initially it goes from 0 to 20 in one direction. It is at rest and comes back in the opposite direction to the same point. So it is going to be like from A to B and back to point A. But for distance, we have to calculate this 20 meter and this 20 meter. We have to add them together. So the total distance traversed is going to be 20 meters in one direction, 20 meters in the opposite direction. Since we don't consider the direction, we add them together. 40 meters is the total distance traversed by the object. The second one, what is the displacement of the object at the end of the journey? So here displacement, of course, from the graph you can see it started at 0 and stopped at 0. So displacement is also 0. Here you can say displacement is equal to 0. When it is 0, you can even say 0 or 0 meters. The next question, calculate the maximum velocity of the object. The maximum velocity is obtained when the displacement is in one direction. Here it takes 10 seconds, but here it moves in the opposite direction but within a different time period. So here it has taken 10 seconds for the movement in the opposite direction from 14 to 20 seconds. So that means it has taken 6 seconds for the object to move or travel the same distance. So here when they ask you to calculate maximum velocity of the object, we have to consider the maximum magnitude. So therefore it will be at this part of the motion. So here the displacement is 20 meters and it is in 6 seconds. In order to mention that it is in the opposite direction, we will be using a negative value because velocity is going to be rate of change of displacement. So that is displacement over time, which is the gradient of this plot. The gradient of this plot. So here if we take the gradient, it is going to be 0 minus, that is the final 0 initial is 20, 0 minus 20 divided by 20 minus 14. We have already calculated 6 seconds. So when we subtract 20 from 0, it is going to be minus 20 meters divided by 6 seconds. That will be equal to minus 3.33 meters per second. So here the velocity is 3.33 meters per second but in the opposite direction. If you can remember the question, I will go back to the question. Here it said it is to the north. So now the object has moved towards the south. So we will come back to the question. Here the velocity is going to be in the opposite direction. So again I will write it as velocity equals 3.33 meters per second towards south. I hope students, when you get a negative value, you will remember to consider the opposite direction. So in this, since they said the initial motion is towards the north, we write this as towards south. Okay, we'll go on to the next question. Find the distance traversed by the object during 10 to 14 seconds. So, if we consider the time period 10 to 14 seconds, you can see it is a flat graph, a straight line parallel to the x-axis. So, that means when we look at the displacement, it does not change. The displacement is in the same position. So, the object is not moving. That means the object is not traveling a distance. When they ask you to find the distance traversed by the object during 10 to 14 seconds, since the object was at rest, there was no displacement, so there is no distance traversed. So, distance traversed will be 0. Will be equal to 0. So, that is how we get information from a graph. Always in a displacement time graph, when the graph is parallel to the x-axis, there is no displacement. Therefore, there is no distance traversed. We will go to the next part of the question. So, the next one, plot the velocity time graph for the above motion. So, we will get the values from the previous question. Here, the first part of the motion, as you can see, 20 meters, the time taken is 10 seconds. We will take the velocity as v1. That will be equal to 20 meters divided by 10 seconds. We did not calculate this before. So, it is going to be 2 meters per second in the north direction. That is the first part of the motion towards the north. The second part of the motion, we already calculated the velocity. I will take it as v2. If you can remember, it was equal to minus 3.33 meters per second. It became minus because it was the motion in the opposite direction. So, when we need to plot a velocity time graph with a positive velocity and a negative velocity, that is velocity in the first direction and the velocity in the second direction, we will have to mark the zero line in the middle of the graph. So, you will have the positive y values and the negative y values. First, I will mark the axis. The x-axis will be time, t seconds, and the y-axis will be velocity, meter per second. So, we will have to mark the values. Here, the velocity is going to be 0. In one direction, we will mark the velocity as 2, 4. We will be only needing the 2 meter per second velocity. In the other direction, it is going to be minus 2 and minus 4. And time, first is 10 seconds. I will go back to the previous slide. So, you can see 10 seconds, then 10 to 14 seconds, there is no displacement. So, it is rest, and then 14 to 20 seconds. We will have to mark the same values here. So, initially it's going to be 10 seconds. Then we have the 14 seconds and 20 seconds. So, 10, 14 and 20 seconds are marked. So first part of the motion velocity is 2 meters per second. That is this value. Therefore, that is going to be a constant or uniform velocity for the first 10 seconds. I will plot the graph now. So 2 meters per second for 10 seconds. It will be a straight line starting from 0 seconds up to 10 seconds. Then there is a rest period from 10 to 14 seconds. So I will mark that like this, and we will be connecting the plots using dot lines or broken lines. Then it is convenient to get information from this. So from here to here, it's the point where the 10-second time period is over. Then from 10 seconds to 14 seconds, there is a rest period. Again, from the 14th second to the 20th second, the object moves with a velocity of minus 3.33. So to mark that value, it will be 3 is somewhere here, 3.33 will be somewhere at this point. So if I mark that value, it will come to here, as well as we will be drawing a line to show this point of time, 14 seconds. Then if I plot the graph, it is going to be from here to here, that is minus 3.33 meters per second from the 14th second to the 20-second mark. That is the end of the motion of the object. If you want, you can also use another broken line to show this end of the reaction point. So here you can see initially the velocity is 2 meters per second in one direction, then a period of rest, and finally the minus 3.33 meters per second, that is velocity in the opposite direction. So this will be the velocity time graph for the motion of the object. I hope you got a good understanding as to how we draw the graph when it comes to a motion in opposite directions. So positive value and negative value for the velocity. Now we will go on to the next question. This is extra exercise 3. A train at the railway station starts its journey from rest and accelerates uniformly in a straight line for a period of 20 seconds and acquires a maximum velocity of 20 meters per second. So here you can mark the values. Initially it starts from rest and then it accelerates uniformly in a straight line for a period of 20 seconds and acquires a velocity of 20 meters per second. So it will be accelerating. Then it continues the journey with the same velocity for a period of 120 seconds. So here same velocity. And finally, then it decelerates for a period of 10 seconds and comes to rest at the next station. So the train started at one station, increased its speed, that is accelerated, and reached a speed of 20 meters per second, that is the velocity at the end of 20 seconds. And then the same velocity for a period of 120 seconds and finally decelerates for a period of 10 seconds and stops at the next station. So if we look at the questions, plot the velocity time graph for the above motion, calculate the acceleration of the train during the first 20 seconds, Find the distance traveled with acceleration. Calculate the deceleration of the train before it stops at the second station. Find the distance traveled with deceleration. Use the graph to find the distance between the two stations. We will go to the first question. Plot the velocity time graph for the above motion. So, to plot the velocity time graph, we will have to mark the axis first. So, as you all know, this is a motion in one direction. So, we can normally use the graph. So, x-axis is time, t seconds, and the y-axis is velocity, v meters per second. So, here initially we will mark we mark the time. Initially it's 20 seconds. Then another 120 seconds. And finally 10 seconds. We will mark the values on the x-axis first. So, the train moves for 20 seconds. So, 10, 20 seconds. Then it moves for 120 seconds. So, 20 plus 120 up to 140 seconds. So, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. We can mark it up to 140 seconds. And finally, another 10 seconds. So, it will move up to 150 seconds. First 20 seconds, then another 120, so it's 140 seconds. And finally 10 seconds, so it's going to be 150 seconds. Here the velocity, the maximum velocity reached was 20 meters per second. So, we can mark that value here at 1.20 meters per second. Now, I will draw the graph for this motion. Initial part where the train starts from 0 and reaches a velocity of 20 meters per second. Okay. So, I am sure children you can draw to the exact point. So, it has to start from 0 and come to a velocity of 20 meters per second. Then it continues the journey with the same velocity for a period of 120 seconds. So, it has to be a line parallel to the x-axis starting from 20 meter second point, that is from here to here, and until the end of 140 seconds. We will have to have uniform velocity. So, I will plot that starting from here to here is uniform velocity. Then for the last 10 seconds, it is going to be deceleration and the train comes to stop at the next station. So, from here again, it comes to 0 at the end of 150 seconds. So, this will be the graph for the movement of the train, starting from one station and stopping in the next station. So, this is the velocity time graph with three parts of the motion. Acceleration where velocity increases, so uniform acceleration, then constant velocity and uniform deceleration. And the shape of the curve is going to be a trapezium. We will go to the next part. The graph that we drew before is given to you so that we can use the information to do the calculations. Calculate the acceleration of the train during the first 20 seconds. So, this part is where we have the acceleration, first 20 seconds. If we calculate acceleration is equal to I'm sure by now you remember it by heart. When we use a graph, the acceleration is equal to what? Yes, it is the gradient of the graph. So to calculate the gradient, we need the difference in y-axis, 20 minus 0 divided by difference in x-axis, that also 20 minus 0. So when we calculate 20 divided by 20, will give you a value of 1 and the unit will be meters per second squared. How do we get that? Okay, in this graph, the axis is not shown. So, the axis will be, this is velocity in meters per second, and the x-axis we have time in seconds. So, when you divide meters per second by seconds, you get the unit as meters per second square. Look at the next part. Find the distance travelled with acceleration. So, here we need to calculate the area of this graph, that is the part of the motion where the train travelled with acceleration. So, here the shape is a triangle. So, how do we calculate the distance travelled? Yes, we calculate the distance travelled using the area of the triangle. That is the area under the graph. So, distance equals area of the triangle. That is equal to half into base into height. That is equal to half into base 20 and height 20. You can simplify 2 and 20, you get 10. So 20 into 10, it will become 200, and since it's meters, it's the distance. The meters is obtained by multiplying meter per second by seconds. The base is seconds and 20 height is meters per second. So, you have the unit meters for distance. Okay, we will go to the next question. Calculate the deceleration of the train before it stops at the second station. So, to calculate the deceleration, again we have this part of the graph where it starts at a velocity of 20 meters per second and finally reaches rest, that is velocity 0, and the time taken is 10 seconds. 140 to 150 seconds. It was given to you in the question, the last 10 seconds. So, we calculate the deceleration, but when we write the equation, we have to write it as acceleration, and acceleration is equal to, yes, gradient that will be equal to 0 minus 20. Final y minus initial y. Final is 0, initial is 20, and time 10 seconds. So, you are going to get a negative value, negative 20 meters per second divided by 10 seconds. So, that will give you an answer minus 2 meters per second square. Since you get a negative value for acceleration, you can confirm that it is deceleration. So, what do you do now? You have to rewrite it as deceleration equals 2 meters per second square. So that is how we calculate the deceleration of the train. The next part, find the distance travelled with deceleration. So to find the distance, we need to find displacement. So to find the displacement from a velocity, that is meters per second, and time graph, time in seconds, we need to find the area under the curve. So here, if we mark the area of the curve, it is going to be this part, the area of the small triangle at the end of the graph. The last bit of the trapezium where the train decelerates and comes to a stop. So we need to calculate the distance. Distance is equal to the area of the triangle. That is equal to, you know very well by now, half into base into height. To find the base, we have to calculate the value here. It is known to you, 10 seconds, 140 to 150 seconds, and the height is 20. So if we substitute the values, half into base 10 into height 20, we can simplify the values. 2 and 20, you get 10. So 10 into 10, the answer will be 100 meters. So that is the distance travelled with deceleration. So by now, you have got a good understanding as to how you can calculate different values by looking at a graph. We will go to the next part of the question. Use the graph to find the distance between the two stations. So when we say distance between the two stations, that is the total displacement of the train starting from one station going and stopping at the second station. So when we talk about the total displacement, we have to consider the full graph. So as you know, this is a trapezium. We have discussed this before. A trapezium, we need to calculate the area under the trapezium. That is the area under the graph. So total distance or the distance between the two stations. Distance between the two stations. That is equal to area of the trapezium. Here you need to know the two sides. If we write the equation for the area of the trapezium, what is the area? Yes, it is the average of the two parallel sides. So A plus B divided by 2 into the perpendicular height. If we mark the sides A and B, these two are the parallel sides. So this is going to be A. A starts from 20 and stops at 140. So that value is going to be 120. 140 minus 20. 120, and B is going to be the full length 150. We will substitute the values here. 120 plus 150 divided by 2 into the perpendicular height h. That is this value 20. So we write that here 20. 120 plus 150, it's going to be 270 divided by 2 into 20. You can simplify these two. This will become 10. So it's going to be 2,700 meters. That is the total distance travelled by the train between the two stations. So this is how we calculate the total distance. That is the area of the trapezium when we consider the full motion of an object. Here it is a train. With this question is over. We will go on to the next question. Extra exercise 4. A ball was thrown upwards with a velocity of 20 meters per second and the gravitational acceleration is given to you 10 meters per second square. So when you throw something up, a ball upwards, it's going to move upwards, but the gravitational acceleration is going to work downwards. So therefore, it is going to be a deceleration. Calculate the time taken for the ball to reach the maximum height. So as you know, we know the acceleration. We know acceleration is rate of change of velocity. Initial velocity is given to us 20 meters per second. You all know always an object thrown upwards will go to velocity 0 at the maximum height. Will reach velocity 0 at the maximum height. So there we know the velocity initial and the final velocity. We don't know the time. So using the equation for acceleration, we can calculate time. So if we write the equation, I will write it using the symbols. Acceleration A will be equal to the final velocity, I will use it as V final, minus initial velocity as Vi divided by time. So if we rearrange, the time will go up. Time will be equal to final velocity minus initial velocity divided by acceleration. Here we are rearranging the equation and making the time as the subject of the equation. And when we substitute the values, you know the initial velocity is 20 but the final velocity is 0 minus 20 divided by the gravitational acceleration becomes deceleration here. So that is going to be minus 10. Therefore, we get the values as minus 20 divided by minus 10. That is going to be 2 seconds. So the time will be 2 seconds. The object will reach the maximum height in 2 seconds. So here the object is the ball. So the ball will go to its maximum height at the end of 2 seconds. Find the maximum displacement of the ball. So here displacement is the maximum height, and since the ball is moving with uniform deceleration, we can find the displacement. Remember the equation? Yes, displacement is equal to mean velocity into time. So here we will use the equation displacement equals mean velocity into time. So that is going to be mean velocity 0 plus 20 divided by 2 to calculate the average, and time we have calculated 2 seconds. So it's going to be 20 divided by 2 into 2. That will be equal to 20 meters. So the displacement, that is the maximum height reached by the ball, is going to be 20 meters. The next one, draw the velocity time graph for the motion of the ball from the time it was thrown upwards until it reaches the ground again. So I will go to the next page. Right. So here we need to draw the velocity time graph. So again I will be marking the axis, and going back to the question, here you can see the ball was thrown up until it reaches the ground again. Remember students, we did a similar example. When the ball goes up, it is the motion in one direction where the ball will be decelerating. Then after reaching the maximum height, it will come down towards the ground. Then it will be accelerating in the opposite direction. So therefore, we will have to use the positive and negative parts of the y-axis. So velocity time graph, I'll go to the next slide. This will be velocity, the y-axis, velocity v meters per second, and the x-axis is marked in the middle, time t seconds. So here it is going to be the 0 point, because we need to have the positive values and the negative values. So if we go back to the slide where we calculated, the time taken was 2 seconds and the initial velocity is 20 meters per second. So as you know, initially it has to start from 20 meters per second. By the end of 2 seconds, it has to come to 0, and again it has to reach a velocity of minus 20 in another 2 seconds. So I will mark the 2 seconds here, and another 2 seconds will become 4 seconds, and the initial velocity is 20. The same way, the final velocity will be minus 20, because it is in the opposite direction. So when we plot the graph, it is going to be a straight line. Initially it is going to decelerate, reach a velocity 0, and accelerate in the opposite direction. I will mark the points first so that we can identify the coordinates easily. It has to come up to this point. So if I plot the graph now, it will start from 20, reach 0 at the end of 2 seconds, and finally come to minus 20 at the end of 4 seconds. So here you can see, since this ball goes up and comes down, we have the graph in the positive and negative parts of the y-axis. One direction going upwards, the opposite direction, the ball coming downwards. So this is how you are supposed to plot a graph when it involves a motion in 2 directions as well as acceleration and deceleration. So here velocity decreasing, deceleration, velocity increasing in the opposite direction, acceleration. Okay students, I hope you got a very good understanding about the different quantities that we discussed under this lesson and the graphs related to them and all the calculations. With this, it is not sufficient. You will have to practice all these questions, the questions from the miscellaneous exercise in your textbook and the extra questions, when you keep on practicing them, you will be able to get a better understanding and you will be able to do the calculations faster and correctly. So I hope with this you are able to do all the calculations related to motion in a straight line.